right, so in section 3.3, we're going to look at what's called the factor theorem. And the idea is that we're going to try to be figuring out, when you set an equation equal to 0, how do you solve it? All right, sometimes it's pretty straightforward. Like if you had something like this, like 3x plus 2 equals 32, right? We could easily solve something like that because it's just subtracting 2 from both sides and then dividing by 3. So that one would be pretty straightforward. Sometimes we've got ones that are a little more complicated, and we'll have to try something else first to try to solve it for x. All right, so let me make up an even simpler one. X plus 2 equals 0. If I wanted to solve this equation for x, okay, what would I get for an answer? Yeah, negative 2. So negative 2 in this equation is what you call the 0 of the equation. It's the number you can plug in for x, and then you get 0 as the answer. That's also called a root. So negative 2 is the 0 of this equation. It's also called the root of that equation. And it is the only number. There is no other number besides negative 2 that works. So just to write down what that means, a root or a 0 is a number that you can plug in, and when you plug it into your formula, it equals 0. So on the one up above, again, it is negative 2. Okay, so any question on that idea? What it means if a number is a 0 of an equation? Yeah? Yeah, go ahead. Okay, so what we're going to look at first is using long division to find a root of a polynomial. Okay, I'm going to show you an example first with numbers, and then we'll look at an example with a polynomial. So let's say that I wanted you to factor the number 12. I want you to factor the number 12. That means I want you to take the number 12 and write it like that. Something times something. Now, I'm going to tell you that 3 is a factor of 12. I'll tell you that 3 is a factor. How could you use the fact that 3 is a factor to find the other one? Yeah?
Divide 12 by 3.
Yeah. Take the one that you know is a factor and divide 12 by it. And you get the other answer that goes there. And then we're going to do exactly the same thing, except with a polynomial. And does anyone remember what we called this number when you divide 2? Like we just divided 12 by 3 and we got 4. When you divide two numbers, the thing you get is called the what? Anyone remember? The quotient. Yep. When you divide two numbers, you get the quotient. So here, same thing again. I just wrote it all out. So if you want to factor the number 12, and you know 3 is a factor, that means 3 times something will give you 12. To solve for the something, divide each side by 3. 12 divided by 3 gives you 4. And then you could check it by plugging it back in. 3 times 4 equals 12. Now, when we divided 12 by 3, what was the remainder? Yeah?
4. Oh, wait, what?
4 was the quotient. What's the remainder when you divide 12 by 3? 0. That's very important. If I'm telling you that something is a factor of something else, that means you can do division and get a remainder of 0. Remainder of 0 means it goes into whatever you're dividing evenly. If I took the number 5, if I divide 12 by 5, do I get a remainder of 0? Let's go. I get a remainder of 2. because I get a remainder that's not 0, that means 5 is not a factor of 12. 5 doesn't divide into 12. So if it does divide in evenly, that means it's a factor, and that means you get a remainder of 0. I basically just said that to you guys. If you divide two things and you get a remainder of 0, then that means what you divided by is a factor. So if we took 24 divided by 6, what do you get for a remainder when you divide the 24 by 6? About the camera? 0. That means 6 is a what? 6 is a factor of 24. And if you wanted to find the other factor, 6 times something gives you 24. Divide that out and you get 4. So 4 is called the quotient, and that is the other factor. So this quotient is the thing we're going to want to try to find today. So we're going to look at doing the exact same process now, except we're going to do it with a polynomial. So if I told you, let's say x squared plus, let me make up something that would work, 4x plus 3. And I wanted you to factor that. And I'll tell you that x plus 3 is one of the factors. If you're not sure how to find the other one, it's the same way you do it if I told you 12 is a factor. 12 is a number we want to factor. How do you get the other one? You divide. That gives you the other one. Would be the same thing here. If you divide x plus 3 into x squared plus 4x plus 3, you will get the question mark. Division is a little, it's a little bit more complicated than just dividing two numbers, but it's still the same idea. And I'm going to show you how you would divide these two things using what's called long division. So what I'll do is I'll put up a step, and then we'll do the step in a problem, so you can kind of see how the step looks when you do it. There's 5 steps, so I would probably write down the first step, and then leave enough room to write like 4 more lines after that, and then below that we'll do this problem. All right, so first of all, just to be clear about a couple different terms. When you're dividing, this is called your dividend. That's the thing on the inside. The divisor is what's on the outside. Other words you can use are like numerator and denominator. So like if you had 3 divided into 12, what that really means is 12 divided by 3. 12 is called your dividend. 3 is your divisor. It's what you're dividing by. You can also call it denominator. So, when we want to divide something into something else, first thing we have to make sure of is whatever we're dividing into has every term represented from the highest to the lowest exponent. What's our highest exponent in this problem for my dividend? 3. So I need to have every exponent from 3, 2, 1, and 0. If I'm missing one, then I'm going to fill in a 0 for that term. Is there any terms I'm missing in my dividend? In this case, yeah. I'm missing the x squared. since we're missing it, how many of them do we have? We have 0 of them. So let's fill in a 0. We have the x cubed. We don't have the x squared. We didn't have the x. Well, we have the x and the plus 3. All right, so that's the first step. Second step, it says divide the first term of the divisor. That's that. Into the first term of the dividend. That's that. So we're going to divide the first term of the divisor, which is x, into the first term of my dividend. So what we're really doing is that. Okay, x cubed divided by x. All right, so we're doing our step 2. Dividing x into x cubed. And when you divide x into x cubed, what do you get? Yep.
X squared.
Yep, you get x squared. You put that answer up above the line, and then we go on to the next. Okay, next up. We're going to take the answer that we just got in step 2, and you're going to multiply that answer by each term in the divisor. So you're going to kind of do something like this. You're going to multiply the answer from step 2 by each term in the divisor. And here it's important that we line up like terms. So we're going to put our answer under the appropriate term. And when I mean appropriate, I just mean put all the x squareds in a column, all the x's in a column, and so on. So once we get that step, I'll make the other side bigger again. Again, multiply the answer from step 2 by each term in the divisor and put the result under the appropriate term. Okay, so let's multiply this out. Keanu, what's x squared times x? Yep, x cubed. Okay, so there's the first part. Austin, what's x squared times negative 3?
Is there 1 under the 92?
Is there a 1 under what?
Do you say x squared times negative 3?
Yeah, basically. There's not really much you can do with that.
Oh. Is it x to the 4th?
No, that'd be if you had like x squared times x squared. That'd be x to the 4th.
Okay.
So we have negative
3x.
Negative 3x squared. Yeah, there's not really much we can do with it. X squared times negative 3 is just negative 3x squared. And that's it for that step. Okay, the next step is to subtract. So you're going to subtract the columns from the last step. Okay, so subtract. All right, let's go back there. The way I like to write subtraction is I go like this. Minus. And put that whole thing in parentheses so you remember to subtract both of them. And now we do the subtraction vertically because that's how the like terms are lined up. Curtis, what's x cubed minus x cubed?
0.
0. That should happen every time. Something should cancel out just like that. Okay, the next one, Tony, what's 0x squared minus 3x squared?
3x squared.
Good, 3x squared. Okay, so notice what we have now. 3x squared, the exponent here is a 2. The exponent in our problem here started with a 1. We have to keep going. You know to stop when this exponent is smaller than that. It started as a 3, now it's down to a 2. When we do it again, it'll be a 1. So it goes down usually by 1 each time you do this. So now the next step is bring down the next term and repeat what we just did. So bring down the next term and repeat. And you know to stop if one of two things happens. Either you end up with a remainder of 0, which we talked about that a few minutes ago. Something gets a remainder of 0, we know it's a factor. Or, once the degree of your remainder is less than your divisor, you're done. Right? You can't divide like x cubed into x. That doesn't work. You can't take something with a bigger exponent and divide it into something with a smaller exponent. So, can't do that. On this problem, we are not going to get a no remainder. We're going to know we're done when the degree of the remainder is less than the divisor. So the degree here is a 2. Degree here is still a 1. Okay, so bring down the next term. And now repeat the process. Take the first term here and divide it into the first term there. So Cameron, if I take 3x squared and divide by x, what do I get? Just be 3x. Yep. Now multiply that 3x back out. Grady, what's 3x times x? 3x squared. And Sam, what about 3x times negative 3?
Would be negative 9x.
Negative 9x. Okay, so we divided it in. We multiplied it back out. And then what do we do with these columns? 1. Do you remember what we do with the columns? What did we do with the columns at the last step? The one right above. Do you have the steps written down?
Yeah.
So just, look back at your step. What's the step right before the repeat? We're at where the repeat is the last step, but it's the step before that. Subtract. Yep. We're going to subtract those columns. Notice when you do this kind of problem, the work always goes down and to the right. So if you have to do a long division problem, start on the left. Don't start on like the right edge of something because you're going to run out of space. All right, so let's subtract. Gavin, what's 3x squared minus 3x squared? What's 3x squared minus 3x squared?
3x squared minus 3x squared. Wouldn't that cancel out?
Yep. So again, that's always supposed to happen, so that's gone. And Ryan, what's negative 8x minus negative 9x?
Would be negative 17x.
If you had that, you would get negative 17. Negative 8 minus
1.
9.
Oh, positive?
Right, because that's going to become negative 8 plus 9.
Okay.
So that's going to be negative x. And bring down your next term. We know this is the last time we have to do it, because the exponent on this is a 1. The exponent on this is a 1. Once this exponent is smaller, we're done.
There should just be another x in that.
Oh, positive x. Is that what you're saying? Yeah. Okay. Didn't mess us up. Yeah, but that would have messed us up right now. Yep. Yep. Just sign out. Oh, Tyler, can you tell me? I'm going to divide x into what now? Just the x. And what do you get if you divide x into x? Yeah, just 1. This part right here, that is your quotient. Okay. All they ask you for in a problem is the quotient. You're done. If they want the remainder, we just need to finish it off. So multiply the 1 back out. 1 times x is x. 1 times negative 3. Negative 3. And 1, what do I do with the columns? Yep, I'm going to subtract them. X, take away x, that's gone. And what's 3 minus minus 3? Yeah?
That'd be 6.
That's 6. And what do you think the 6 is? That's my remainder. So in this problem, the quotient is x squared plus 3x plus 1. And the remainder is 6. Since I got a remainder of 6, what do you think that means about x minus 3 if you try to divide it into that x cubed? It's not a factor. So if you were trying to factor x cubed minus 8x plus 3, that is not the way to do it. That is not right. So x minus 3 doesn't work. That's one way you can write your answer. Let me show you one other one. If you had 17 divided by 5, I'm going to show you how you can write this one the same way we did, and then I'll show you the other way you can write it, and we'll apply that same idea to this problem. What's the quotient when you divide 17 by 5? Yeah? Well, 17 is your numerator. But what's your quotient? That's when you do the math of it. Yep, 3. So your quotient is 3. And what do you get for a remainder? Yeah, 2. So the way they taught you to check this answer is you basically take your quotient plus your remainder over your divisor. That's another way you can write the answer. So the answer to 17 divided by 5 is 3 plus 2 fifths. That's the answer when you divide 17 by 5. Quotient plus remainder over divisor. That's 3 and 2 fifths as a mixed number. Quotient plus remainder over divisor. Let's do the same thing here. So the other way you can write this answer is quotient plus my remainder over my divisor. X minus 3. It's exactly the same idea. Either answer is correct. Which way could you do it? If the directions didn't say, do it any way you want. Questions on that? Yeah.
So for the x minus 3 right there, did you just get that from the divisor?
Yes. That x minus 3, the thing on the outside, that's called your divisor or your denominator. And that's the divisor. All right, let's try one more of those and see what happens here. This time, the highest exponent in your dividend is a 4, and they already filled in everything that was missing. You were missing the squared and the first power, but they filled them in as zeros. Okay, so take the first term here, divide it into the first term there. If you want to think in your head, well, what are we really doing off to the side? You're doing this. 2x to the 4th divided by 2x squared. So, Naisha, what do I get when I do 2x to the 4th divided by 2x squared? All right, what does 2x to the 4th mean? Like, let's say you had to explain this 4 that's higher than the x. How would you explain to somebody what this 4 means that's higher than the x? Like, how would you write it? You have a 2, right? And then what else? Okay, and how about the bottom? Just x times x like that? With the 2. So when you want to divide this out, you cancel out anything that's in the top and the bottom. What's in both the top and the bottom here? So, yeah, we have 2 x's. Okay. And the 2's. So what are you left with?
It would be x squared.
X squared. Yep. Okay, so we get x squared. Now multiply that back up. X squared times 2x squared is 2x to the 4th. Abigail, what's x squared times x? Yep, it's x cubed. Dustin, what's x squared times 1? Just be x squared. And now subtract those columns. That's gone. We're left with negative x cubed minus x cubed. That's minus 2x cubed. Negative 1x cubed minus another x cubed. It's like negative 1 minus 1. That's negative 2. 0 minus x squared is just minus x squared. And bring down your next term. Now, this is going to be the last time we have to do this step in this problem. You're going to see, for some reason, something's going to happen here, and we're going to be done at this step. So Jackson, for our next step, we're going to divide 2x squared into negative 2x cubed. So off to the side, that's what we're doing. Can you tell me what you get when you do that?
Negative x.
Good. Negative x. And Dominic, what's negative x times 2x squared? Yep. 2x cubed. And how about negative x times positive x? negative x squared. And the last one is negative x times 1, which is negative x. Okay. Now, watch what happens here. Kiana, what am I supposed to do with these columns? Subtract them. All right. And Austin, what's negative 2x cubed minus negative 2x cubed? 0. That's gone. Curtis, what about negative x squared minus negative x squared?
Cancels out.
That cancels out too. If two things cancel in the same step, that's nice because that means it's going to save us time. Okay, so two things cancel. All that's left is 0 minus x. Tony, what's 0 minus x? X. Now what's the exponent on that x, even though we don't write it?
1.
That's a 1. What was the exponent on our outside problem?
2.
It was a 2. Is 1 smaller than 2? Then we're done. Okay. Only thing we have to do is bring down the 2. This is my remainder. So the quotient is x squared minus x. And the remainder is x minus 2. So at first, it looked like it could have been worse than the last problem because the exponent here was a 4. But if you look at the amount of work on the two problems, I think the one on the right was shorter. Even though this one had a smaller exponent, doesn't always mean it's going to be shorter. Okay, any question on that? Anything else there that anyone needs to copy down? All right. What else? I want to show you something now called the remainder theorem. Now, we can get the remainder if we just do out the whole problem. But there is actually a faster way to get the remainder sometimes. Depends on the complexity of the problem. In this problem, I could have gotten a remainder of 6 a lot faster if that's all they wanted to know.
Could I have your attention, please?
All right, let's look at this problem for a second, then I'll show you what the remainder theorem is. Look at the divisor. What's the number that comes after the minus sign in my divisor? A 3. Okay. The divisor is x minus 3. The number after the minus sign is a 3. Let's plug 3 into what I just circled and watch what happens. You get 3 cubed minus 8 times 3 plus 3. 3 cubed. Right, so all I'm doing is filling in a 3 for x. And if this works, I'll write down what we just did. What's 3 cubed? 3 times 3 times 3. 27. What's 8 times 3? 24 plus 3. What's 27 minus 24? 3. And what's 3 plus 3? 6. And what do we get for a remainder in this problem? 6. So in this particular problem, there is a quick way to find out the remainder. And that's because we divided by something pretty simple. It was just x minus a number. You could do that anytime you're dividing by something here that's x minus and then a number. This one doesn't fit that pattern. This is x squared. So we couldn't do that trick. But when that trick works, it's called the remainder theorem. So if you had something in the top and you divide by x minus a number in the bottom. So I guess I could be more specific. This would be f of x in the top. So you'd have some polynomial here. if you take the number that's after the minus sign and you fill it in for the x in the top, like we filled in 3, and then we had 3 cubed minus 8 times 3, whatever it was. If you take that number and fill it in the top, that will give you the remainder. Now, I said you could only do it if it's x minus a number. So, if you had something like that, you would plug 2 into the formula that's in the top. You'd plug in a 2 to get the remainder. What if you had something like that? Is there a way we can think of x plus 3 as x minus something? Yeah.
So if it is just x plus 3, you can just flip it and then substitute negative 3 for x?
Yeah, you can substitute in negative 3. Because when you do this trick called the remainder theorem, you have to take the number that comes after the minus sign. Well, when you write it as x plus 3, there is no minus sign. Or is there? Could you think of it as having a minus sign? Yes, you could. X minus, now what would come after the minus sign? Minus 3. So now, if you plugged minus 3 into the top, you could quickly find the remainder. So technically, this trick works if it's x minus a number or x plus a number. You just have to be careful if it's plus. Right, you got to kind of switch it. So what I want to do with this is, I don't want to do all the long division. All I want to do is find the remainder. And you might think, what's the big deal? Why do you want to know the remainder? Because if the remainder comes out to 0, then that means something important we said earlier. It means it's a factor. So the remainder theorem is very helpful. Okay, so this is really like 2 different problems. First, they want us to divide f of x by h of x, find the remainder, and then try f of x divided by g of x, and find the remainder. Okay, so let's start with the first one. F of x. I'm not going to write the whole thing out. You can just look at what f of x is. It's right over there. But we're dividing by x minus 3. So what number are we going to plug into the top? Yeah? What's the number that comes after the minus sign? 3. Just the 3. So take the 3 and plug it in for x in that formula. So that's going to give us 3 cubed minus 2 times 3 squared plus 3 minus 5. Okay, we'll just kind of go through it. Grady, what's 3 cubed?
27.
So 27 minus 3 squared is 9. And what's 9 times 2? 18. Plus 3 minus 5. 27 minus 18, what's that going to give me?
9.
Yep, it gives me 9 plus 3 minus 5. What's 9 plus 3? 12. And what's 12 minus 5? 7. That's the remainder. That's a lot quicker than doing long division. Now, if they said to you, find the quotient, well, then you're stuck. Then you got to do long division. But if all they want is the remainder, that's how I can get it real quick. So now, is x minus 3 a factor of f of x? No, it did not go in evenly. You might think, well, does anything ever go in evenly? Because we haven't done one yet that comes out to 0. Yes, yeah, we will. All right, and let's do f of x. divided by g of x. Okay. This time, how do you want to think of the bottom so that it's x minus something? Yep. Yep, so it's x minus, and now think of the number after the minus sign, -1. So what are you going to plug into the top this time? -1. And let's do it again and see what we get. So we get -1 cubed minus 2 times -1 squared minus 1 minus 5. Now, Asia, what's -1 cubed? Yep, because that's a negative times a negative times a negative. That's a negative. What's -1 squared? Yep.
1.
1 times 2.
Oh, 2.
So -2 minus 1 minus 5. -1 minus 2 is -3. -3 minus 1 is -4. And -4 minus 5, -9. So, is x plus 1 a factor of f of x? It had a remainder. Right, so that's the point of the remainder theorem. It's a quick way to check if something is a factor. Any questions on it? Okay. Yeah. You what? Yeah. Okay. So now this problem says use the remainder theorem. So that's what you just learned. If you see any directions in the homework that say use the factor theorem, it's the same as the remainder theorem for what we're doing. So just ignore that it says factor theorem and just pretend it says remainder. So use the remainder theorem to show that x plus 2 is a factor of this. So if x plus 2 is a factor, when I divide x plus 2 into that, what am I going to get as a remainder? Yep, I'm going to get 0. And they're already telling us that it is a factor. They just want us to prove it. Okay, so we'll check it. So you're dividing x cubed plus 5x squared, all that stuff, by x plus 2. But how can I think of x plus 2 if I'm going to use the remainder theorem? Don't think of it as x plus 2. Think of it as x minus what? X minus minus 2. Think of it like, now, Tony, what number am I going to plug into the top? -2. Okay, let's see what happens. So fill -2 in for x. This is the remainder theorem. -2 cubed. 5 times -2 squared. Plus 5 times -2 minus 2. What's -2 cubed? -8. -2 squared is 4. What's 4 times 5? So 20. 5 times -2. And minus 2. What's -8 plus 20? That's 12. And 12 minus 10? 2. And 2 minus 2? 0. Perfect. And that's my remainder. So we just proved that x plus 2 divides into this thing in the top even. Any questions on that? I think it's the first one that actually actually worked. I think we're just about it. Okay, so remember, the very first thing I told you was that if you have a number that you can plug into an equation and it comes out to an answer of 0, that number is called a root. So in this problem, I would say that the root of this problem is 2. I could also say that 2 is a 0 of this problem. So whether I say 2 is a 0, or 2 is a root, or 2 is a number you can plug in and get 0 as the answer, those three things all mean the same thing. Now, I'll go back to the problem we just did to show you the fourth thing I can say. Actually, yeah, that's fine. What number did we just plug into something and get 0 as an answer in this problem? -2. So -2 was what you call a root of this thing in the top, because it's a number you could plug in for x and get an answer of 0. So -2 was a root. But if -2 was a root, what did we prove was a factor in this problem? What was it? Right. We proved -2 was a root, because when we plugged it in, we got 0. If -2 is a root, x minus that number is a factor. Or you could say it the way Dominic did, x plus 2. So if you prove that a number is a root, then x minus that number is a factor. That's important. So if you prove that a number is a root using the remainder theorem, then x minus that number is a factor. And the last thing, if I take that equation I had right here, what was it? Y equals x minus 2. 2 is a root. That means it's going to look something like this. What do we call this spot right here? It's the number 2, which means that 2 is a 0, 2 is a root. But on a graph, the number 2 is the what of this line? Yeah? It is the x-intercept. So saying that something is a root, saying that it's a 0, saying that when you plug it into an equation, you get 0 as the answer, or saying that it's an x-intercept, every one of those things mean the same thing. They're all equivalent statements, just different ways of saying the same thing. Usually when you say something is an x-intercept, okay, now you're thinking about writing the answer as a coordinate. When you say something is a 0 or a root, you're talking about writing a single number, like 2. But this is going to be very important in the next problem. So remember, if you know a number is a root, x minus that number is a factor. So what I'm doing in this one is I'm telling you 3 numbers that are roots. I'm telling you that this is a root, this is a root, and that is a root. But a root to what? Well, that's what I want you to find. Yep. So I'm giving you 3 roots, and I want you to tell me the equation that you could plug them into, and that's the answer. So let's start with -2. if negative 2 is a root, then x minus what is a factor?
2.
X minus
Would be -2.
negative 2. What about if 1 is a root? What would be a factor? X minus, what is it? X minus 1. And what about if 3 was a root? X minus 3. Just think if you plugged all these numbers in one at a time, you would get 0. If you plug in 1 here, you get 1 minus 1 is 0. If you plug in 3 here, 3 minus 3 is 0. And if you plug negative 2 in here, well, let's just simplify that. We would get 0. The only thing we have to do is just multiply that together and see what we get. And that's the answer. So now we've just found an equation that crossed the x-axis at certain spots. Negative 2, 1, and 3. Okay, let's multiply it together and see what we get. X times x. X times negative 1 is negative x plus 2x. What's negative x plus 2x? X. And 2 times negative 1? Negative 2. Okay, so there's the first two. And now multiply that by one more and see what we get. Kiana, what's x times x squared? Yep. And Cameron, x times x?
X squared.
X squared. Austin, x times negative 2?
Negative 2x.
Perfect. And then negative 3 times x squared. That's negative 3x squared. Curtis, what's negative 3 times x?
Negative 3 times x, negative 3x.
3x. And Tony, negative 3 times negative 2?
Or 6.
6. Okay, let's see what we got there. So we got x cubed. Let's see. I'm just wondering if I forgot an exponent of 2 somewhere.
Yeah, the second one should be.
This one?
No. X squared.
This one?
Yeah.
X times x is x squared. Yes. Okay. So x squared minus 3x squared. That's a plus 1 and a minus 3, so that's a minus 2. How about negative 2x and negative 3x? Negative 5x plus 6. Let's graph that and see if it does cross the x-axis at negative 2, positive 1, and positive 3. If it does, then we know we did it right. Graphing it is not part of the question. They didn't say you had to. I just want to know if we did it right. So x cubed minus 2x squared minus 5x plus 6. So remember, we're looking for negative 2, positive 1, positive 3. Okay, what do you think? How'd we do? Perfect. Negative 2, positive 1, positive 3. So it's very easy to check your answer. Right. Any questions on that idea? How we took these three numbers and came up with those three factors. That's the whole key. All right. What's the last thing? Okay. So the last thing is the opposite of the problem I just gave you. In the last problem, I gave you the roots and said, work backwards to tell me the equation. Now, here's the equation. Something cubed, 2x squared, all that stuff. I want you to tell me the numbers you could fill in there to make the x value, make it come out to 0. Okay, so find the roots. And they give us a hint, and they say to do factor by grouping. So if you don't remember what factor by grouping is, it's when you take the first two terms and factor out what they both have in common. Take the second two terms and factor out what they have in common. So let's start with the first two. What does x cubed and 2x squared both have in common? Yeah, do you know what they have in common?
Could you repeat that?
What do these both have in common that you could factor out?
X squared.
Yep, perfect. So factor out an x squared. Sam, if I factor out x squared from x cubed, what am I left with? Just x. And what if I factor x squared out of 2x squared? 2.
Thank you very much.
Yep.
Sorry for the interruption.
Oh, no problem. You can check it by just distributing it back out and see. You go right back to where you started. X squared times x is x cubed. Yep. X squared times 2 is 2x squared. Perfect. Now, the whole thing with factor by grouping is you need to get x plus 2 again. If you don't, factor by grouping doesn't work. So let's see what we could factor out of those two. Does anybody see a number? We could factor out of both of them. And this time it's just a number. There's no letter. Yeah?
4.
4? I'm going to even do a negative 4. Just let's watch what happens. Negative 4 times what would give you negative 4x? Yep. X. And negative 4 times what would give me negative 8?
2.
Positive 2. And look what just happened. X plus 2, x plus 2. Perfect. Now, look at that, and look at that. What do both of those things have in common? Inside the parentheses, yeah, what is that? X plus 2. So what we're going to do now is we're going to factor out what this and that have in common, which is x plus 2. If you factor it out of the first one, it's gone. And what's left there? Just x squared. And if you factor it out of the second one, it's gone. What's left there? Negative 4. And now we're at the last step. We have something times something equals 0. This whole thing times that whole thing equals 0. What's the only way you can multiply two things together and get an answer of 0? If one of them has to be a 0. You have to multiply by 0 to get 0. Either find a number that you can plug in here to make that 0, or find a number you can plug in here to make that 0. What would make this first factor 0? Negative 2. There's one of the roots of this equation. How would we solve this one? What would be your first step? Add 4. And the last step? Take the square root. Now remember, when you take the square root of a number, how many answers do you get? 2. What's the square root of 4? 2 and negative 2. Now, we ended up here getting one of the answers we already had. Sometimes that happens, sometimes it doesn't. The negative 2 answer is what we call a repeated root. It came from here and it comes from here. You don't have to write that it's repeated. If this was a problem on a test, all you'd have to write down is 2 answers to this problem. 2, negative 2. That's it. And that's called factor by group. Questions on that? All right. So that pretty much covers section 3.3. So homework tonight. Well, I don't want to say 9 through 19 because I skipped 11. I was just going to write 9 through 19. I'll have to simplify it, but that wouldn't be right. So, yeah, just copy down those questions. I think it's like 12, might be about 12 or so questions. All right, so tomorrow we'll go over that, and then we'll look at our first section in chapter 4, which is 4.1.